Hello, this is Abrar Ahmed from AADS department. The role of dynamic in rocket system is my topic. Let's get into this topic.
Rocket system, rocket dynamics. There are four rocket dynamics: force on the rocket, drag, rocket stability, rocket equation, specific impulse. Force on a rocket, equation of motion. We know that F is equals to ma. Force at the center of the mass. F gravity is equals to m into g. We know ma is equals to g. Thrust, F thrust is equals to d by dt of mv. The thrust force seen by the rocket is equal to rate of change in momentum carried out away in the exhaust thrust. Assuming that the propellant speed is approximately constant, then F thrust is equals to mp into ce, where ce is speed of exhaust, mp is rate of change in propellant mass. In other words, how fast you go to depend on the speed of the propellant, the mass available in propellant. Third, force drag, resistance from the air to rocket motion. D is equals to half into rho into v square into a into cd. Rho is mass density of the air. Sea level, at sea level, mass density of air is 1.2 kg by meter cube. V is rocket speed. A is speed of rocket perpendicular to rocket flow. CD is coefficient of drag. There are three forms of drag, and their relative importance is highly depend on speed on rocket relative to the sound speed. To match number, V by Vs minus 1050 feet or 331 meter per second. Types of drag. Skin friction arises from friction of the fluid against the skin of the object that is moving through it. Skin friction arises from the interaction between the fluid and the skin of the body. We can see the pictures. Pressure drag or form drag arises due to form of the object. That generally size and shape of the body is a most important factor in form of drag. Bodies with a large apparent cross section will have a higher drag than thinner bodies. Sleek design or designs that are streamlined and change cross sectional area gradually also critically for achieving minimum drag. Wave drag caused by formation of shock waves around the aircraft which radiates away a considerable amount of energy, producing enhancing drag. Although shock wave are typically associated with supersonic flow, they can form at a much slower speed at the area on the aircraft where local airflow acceleration to supersonic speed. The effect is typically seen at a transonic speed above about a match 0 0.8, but it is possible to notice the problem at any speed over that of the critical match of the aircraft wings. The magnitude peaks at about 4 times the normal subsonic drag. It is powerful that it was thought for sometimes that engine would not able to provide enough power to easily overcome the effect, which leads to concept a sound barrier. We can see the graph. CD rocket unpowered, CD rocket unpowered, CD rocket powered, body skin friction, nose pressure drag, base drag, body pressure drag, fine pressure drag, interference drag, fine skin friction. Rocket stability. A small turbulation will kick the rocket out of the element. Active control of the thrust vector could be used to correct these perturbations. Heavy and expensive positive control system through the use of fines. Success depend on the relative position center of pressure relative to center of the mass. Rocket equation, we know that mdv by dt is equals to dm by dt into ve. We know that 1 by integration of 1 by x into dx is equals to log x, where delta v is equals to ve into log of m naught by mf. Specific impulse, it is the way to describe the efficiency of the rocket and jet engine. It represents the impulse per unit of propellant. The higher of the specific impulse, the less propellant is needed to gain a given amount of momentum. Types of solid rockets: hybrid rocket, monopropellant rocket, liquid biopropellant rocket. About description, advantage and disadvantage. Ignitionability, self-sustainability, solid mixture with central hole and nozzle. Separate oxidizer fuel. Typically, oxidizer is liquid oxidized is liquid and kept in a tank. The other solid with a central hole. Propellant such as hydrogen peroxide or nitrous oxide flows over catalyst and exothermically decompose. Liquid biopropellant and rocket. Two fluid propellant are introduced through the inductor and into combustion chamber and burns.